for this example, we're going to take triangle ABC with the given coordinates, and we're going to do a reflection over the line x equals 2. So whenever I see a lowercase r, that means it's a reflection, and then the subscript is going to be the line that you're reflecting over. So I'm going to go down to the graph at the bottom here, and I'm going to start by graphing the original triangle. So A is -3, 1. Then I have B is 0, 5. And C is -5, 7. So here's my original. Then I'm looking at the line that I'll be reflecting over, which is a line x equals 2. So I'm going to go ahead and draw that line. X equals a number, remember, is a vertical line. So every point on this vertical line has an x value of 2, and then the y values are changing. So this is going to be my line of reflection. So this is the line x equals 2. So in order to do a reflection, you always are going to count the number of units it takes to get to this line. That's how far you're going to travel from it. So if I start at A, I have to go 1, 2, 3, 4, 5 to get to the line. So that means I have to go 5 from it. 1, 2, 3, 4, 5. And we always travel perpendicular to the line of reflection. So then from B to get to the line, it's 2 units, so I have to go 2 more units. And then C, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So there's C prime. So here's my new triangle, and notice that the orientation of these triangles has changed, meaning the order of the letters. So here, ABC, I'm going to the left, where now I'm going to the right. So the orientation changed for those. So I'm just going to go ahead and write the coordinates up top. So A prime would be 7, 1, B prime was 4, 5, and C prime was 9, 7 after the reflection. The next thing that we're going to do is we're going to do a translation. So this is the vector notation for a translation. So this means we're going to be going left 10 and then down 7. Now keep in mind, you could also just subtract 10 from each of these x values and then subtract 7 from each of the y values. So if I do that, I'm going to go ahead and fill in the coordinates. So 7 minus 10 would give me -3. 1 minus 7 gives me -6. 4 minus 10 gives me -6. 5 minus 7 gives me -2. 9 minus 10 gives me -1. And then 7 minus 7 gives me 0. Otherwise, on a graph, I'm going left 10, down 7. So let me just show you on the graph the same process. So I'm starting at A, and I'm going left 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going down 7. So 1, 2, 3, 4, 5, 6, 7. So we end up with the exact same answer as what I had above. It's just counting versus subtracting or adding. So then left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 7, 1, 2, 3, 4, 5, 6, 7. And then left 10 again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 7, 1, 2, 3, 4, 5, 6, 7. So here's C double prime. And then for part C, I want to do a rotation. So since it's a capital R, means a rotation of 90, and it's a counterclockwise rotation. It's counterclockwise because it's a positive 90, so we're going to go counterclockwise. So if we start with, and it says the image of triangle A double prime, B double prime, C double prime. So we're going to start with this green triangle. We need to go 90 degrees counterclockwise. So the direction counterclockwise is going to end up over here. So when we go counterclockwise, it really means you're going to be 90 degrees. It means you're going to be really rotating one quadrant, because remember, each quadrant's 90 degrees. So I'm going to take each of these points, and we're rotating from the center since it didn't specify another point. I'm going to take this triangle, and it needs to end up over here in the fourth quadrant. Because remember, when you label your quadrants, 1, 2, 3, 4, this bottom one's the fourth quadrant because you label them in a C pattern here. So I know that this triangle has to end up over there. So what I'm going to do is I'm going to turn my paper in the direction that I want this figure to go. I want this figure to go counterclockwise. So I'm going to turn my paper one time counterclockwise for 90. If it was 180, it would be 2 times. 273 times because it's how many multiples of 90. So in this case, I just need to do one time. So I'm turning my paper counterclockwise. And then now when I look at my picture, see how the green triangle is where I wanted it to be. I said I wanted it to be in the fourth quadrant. I took it from the third and it needs to go down in the fourth quadrant. So what I'm doing, looking at this picture, I'm going to copy down these coordinates as I see them. So I'm pretending that this is the x-axis and this is the y-axis. So if I look at a double prime, that's really right 6 and then down 3. So that would be a coordinate of positive 6, negative 3. So coordinate of positive 6, negative 3. And then if you look at b double prime, that's over 2, so positive 2, and then it's down 6, so it would be negative 6. Remember, we're reading these as if this is the new x-axis and this is the new y-axis. And then C is at 0, and then down 1, so 0, negative 1. So these are my coordinates after the rotation. So then when I actually want to plot the picture, I'm going to turn the graph back, and I'm going to plot those coordinates. So the coordinates that I have for a double or for a triple prime, I have 6. So 6, negative 3. So it means I'm going over to 6, down 3. This will be a triple prime. And for B, I have 2, comma, negative 6. So this is going to be B triple prime. And then for C, it's 0, negative 1. So I connect, and here's my new triangle after a rotation of the green triangle of 90 degrees. So you can see the center rotation was 0, 0, and you can see that 90-degree angle after I rotated. And then for part B, it says which transformation does not preserve orientation. Any reflections are going to be the answer to this. Reflections are the only transformation that won't preserve orientation. So the only reflection that we did was the reflection at the beginning, which was over the line x equals 2. All of the other ones will keep the orientation the same. Remember, orientation means the order of the letters.